Hello everyone, welcome back to the Numericals on Torsion of Shaft problems. Today we are going to solve two more problems. The first one is a hollow circular shaft is to transmit 300 kilowatt of power at 80 RPM. If the shear stress is not to exceed 16 Newton per millimeter square and the internal diameter is zero point 0.6 of the external diameter. Okay. So find the external and internal diameter, assuming that the maximum torque is 1.4 times the mean torque. Okay. So this is the problem. So very simple. We will solve this problem step by step. So first they have given power. Okay. Transmit 300 kilowatt of power. So that is P. P is equal to 300 kilowatt. 300 kilowatt. So next they have given at 80 RPM, that is N is equal to 80 RPM. Next is if the shear stress is not to exceed 60 Newton per millimeter square. Shear stress they have given, so tau is equal to 60 Newton per millimeter square. Next, the internal diameter is 0.6 of the external diameter. That means internal diameter di. So external diameter or outer diameter is d naught. So di is equal to 0.6 times the d naught. That's what they are saying. Next, you need to find so external and internal diameter, outside diameter and inside diameter, because it is a hollow circular shaft problem. So hollow means you will be having both external as well as internal diameter, di or di and d naught. So it may be small di or capital Di, depends. Okay. So nothing wrong if you use capital Di also. Now, at the end they have given, assuming that maximum torque is 1.4 times the mean torque. Maximum torque. Torque is represented by capital T. Maximum torque is 1.4 times the mean torque. So these are the data which they have given to find external as well as internal diameter. Okay, so let's solve this problem. So first, before starting the problem, please understand the data what they have given. According to that, you need to solve. So first thing is, we are going to assume power. Okay, what is the power equation? Power equation is P is equal to 2 pi nt by 60. So here, instead of T, we are going to take mean torque. Okay, so mean torque we are going to take. So P is 300 kilowatt. So 300 kilowatt in the left hand side. When it comes to right hand side, N value, that is speed, they have given 80 RPM, 80 RPM. So T mean we need to find, so write as it is. In the denominator, it is 60. Okay. So now do the multiplication, 300 into the power of 3 into 60. Okay. Multiply these two. So you will get some value and then divide those value by 2 pi 80. Okay. 2 pi into 80 in the denominator. So finally, the mean torque will be around 35,809.86 in terms of Newton meter. Okay. So now if you use 10 to the power of 3, okay, because 10 to the power of 3 and into 10 to the power of minus 3 Newton meter. If you do this, this one and this one will get cancelled. Again, you will get back the same answer. That's why we are multiplying with 10 to the power of 3. So finally, the mean torque is 35,809.86 into 10 to the power of 3 Newton millimeter. After finding this mean torque, use the condition which is given in the problem. That is maximum torque is equal to 1.4 times the mean torque. Now substitute the value of mean torque in this equation. So 1.4 into 35,809.86 into 10 to the power of 3. This value will give 50.13 into 10 to the power of 6 Newton millimeter. That is the maximum torque, or the torque we are going to use to find external and internal diameter. Okay. So finding the torque is over. Next, we will come to how to find the internal and external diameter. So for that, we are going to use the torsional equation. What is the torsional equation? T by J is equal to tau by R is equal to G theta by L. That is the equation. But in that equation, we are going to use this one. T by J is equal to tau by R naught. Why R naught? R naught is used for hollow circular shaft. So just do the cross multiplication. You will get T is equal to tau by R naught into J, this equation. So in the numerator, tau remain as it is. R naught is the radius. So radius is half the diameter. So again, that's why D naught by 2. I'm writing D naught by 2. So J is the polar moment of inertia. So for a hollow circular shaft, it is pi into d naught to the power of 4 minus di to the power of 4 divided by 32. So when this 2 and this 32 get cancelled, and when you take tau divided by d naught into pi into d naught to the power of 4 minus di to the power of 4 divided by 16. Okay. So from this equation, we are going to use the condition. In the problem they have given, inside diameter is 0.6 times the outside diameter. Di is equal to 0.6 times the d naught. So here you can see the clear equation after cancellation of 2 and 32. The remaining equation pi by 16 times the d naught into tau into d naught to the power of 4 minus di to the power of 4. So in the left hand side, use the torque equation 50.13 into 10 to the power of 6, which we have found out after calculating the mean torque. Next, in the right hand side, pi by d naught by pi by 16 into d naught multiplied by 60. 60 is the shear stress. So into d naught to the power of 4 minus 0.6 times the d naught, as I said now. So internal diameter is equal to 0.6 times the d naught. They have given in the problem this condition. Okay. So in this condition I'm using. So in case of di, I'm substituting 0.6 times the d naught. Very simple. So 0.6 times the d naught to the power of 4. So from this, I'm taking d naught to the power of 4 common. If you take it out, so it will be 1 minus 0.6 times the 4. 0.6 to the power of 4. So here d naught and this one, the one d naught will get cancelled. The remaining equation will be pi by 16, 60 into d naught cube. And 1 minus 0.6 to the power of 4, that value will be 0.8704. And in the left hand side, it is remain as it is 50.13 into 10 to the power of 6. Now, just do the multiplication, cross multiplication. So you will get d naught cube will be equals to 488,8748.344. If you do the cubic of this to the power 1 by 3, okay, if you do this, so that d value will be 169.7. 169.7. That is the outer diameter. Now, by using this outer diameter, use that in this condition, that is di is equal to 0.6 times the d naught. D naught value is 169.7. So times the multiplied by 0.6, that will be 101.83. That is the internal diameter. So outer diameter or external diameter is 169.7 and internal diameter is 101.83. How we got this 101.83? Multiplying with 0.6. Okay. So this condition is already given in the problem. Internal diameter is 0.6 times the external diameter. By using that condition, we are going to find this internal diameter. Okay. So finding the external and internal diameter is over. So we'll continue with the one more problem on torsion of shaft. A shaft is required to transmit 245 kilowatt of power at 240 rpm. Okay, so P 245 kilowatt of power, speed is 240 rpm. The maximum torque may be 1.5 times the mean torque. Okay, so maximum torque is 1.5 times the mean torque. So next is the shear stress. The shear stress in the shaft should not exceed 40 Newton per millimeter square. That means there is a maximum torque. Maximum shear stress. So the shear stress in the shaft should not exceed 40 Newton per millimeter square. Tau is 40 Newton per millimeter square. And the twist 1 degree per meter length. And the twist is 1 degree per meter length. That means 1 meter. The length is 1 meter. So next one is determine the diameter required. Okay, so determine the diameter required if the first condition is the shaft is solid. Okay, so you need to find out the diameter of the solid shaft. That is the first condition. You need to find out the external diameter and internal diameter. Okay, the shaft is hollow. Okay, the shaft is hollow with external diameter. Why is the internal diameter? So this is the second condition. You need to find out the diameter for this condition also, external diameter as well as internal diameter. So for that condition is given external diameter. Okay, for example, D naught, if you assume this as the external diameter. So this is twice the internal diameter. Twice the internal diameter. So for this, they have given G, modulus of rigidity is equal to 80 kilonewton. 80 kilonewton per millimeter square. That means 80 into 10 to the power of 3 Newton per millimeter square. That is the modulus of rigidity. So by using these data, you need to solve the problem. Okay, so this problem is little bit confusion. Okay, it is not like the previous four problem what we have solved. It is little bit different. Okay, so very easy, but little bit different. So it's like just confusion. So they are creating some confusion because they have given the twist 1 degree per meter length. Okay, so based on this, we need to find out the diameter. First, we need to find out the solid shaft diameter, and again we need to use this condition to find the diameter. So we need to compare both the diameter, which is maximum. That maximum diameter we need to take. Okay, so let's see how to solve this problem. So the first condition is to find the diameter of a solid shaft. Okay, so based on these data, along with that condition, modulus of rigidity and D naught is equal to 2 times the DI. Okay, so that is for hollow shaft. Leave it that we are going to consider later in later stages. But as of now, you need to use these data along with the G value, modulus of rigidity. But before this, you need to find out the maximum torque, right? So for finding the maximum torque, you need to find out the mean torque. To find the mean torque, you need to use this equation. So P is equal to 2 pi nt divided by 60, where T is the T mean. So that you need to consider. So P value is 245 into 10 to the power of 3 because 245 kilowatt, right? So 245 into 10 to the power of 3. That is the value of power. So N value, they have given 240 RPM. Okay, so N value, they have given 240 RPM. Just use it in place of N and T mean as it is. So do the cross multiplication and divide it with 2 pi and 240. You will get T mean torque will be equals to 9748.24 Newton meter. That is the mean torque. Now convert that into millimeter because so the shear stress what you are going to consider that will be in terms of Newton per millimeter square. So we need to consider torque also in terms of Newton millimeter. Just multiply by 10 to the power of 3. Very simple. Okay. So just multiply by 10 to the power of 3. So mean torque as of now is 9748.24 into 10 to the power of 3. That is the value. Now, by using this mean torque, so the condition which is given in the problem, so T max is equal to 1.5 times the mean T mean. So substitute here, you will get the maximum torque as 14.62 into 10 to the power of 6 Newton millimeter. That is the maximum torque or torque you need to consider for solving the problem. So now from the torsional equation, you know that T by J is equal to tau by R. Here J is the polar moment of inertia. So polar moment of inertia equation is for a circular shaft, it is pi d to the power of 4 divided by 32. So here, so J is pi d to the power of 4 divided by 32 tau and R value, it is half the diameter, so D by 2. So 2 ones are 2 16s are D and here 1D get cancelled. The final equation what you are going to get for finding the diameter of a solid shaft in terms of torque is T is equal to pi d to the power of 3 divided by 16 into tau. So from this, t in the left hand side, it is 14.62 into 10 to the power of 6. So this t value, and in the right hand side, tau value is 40 Newton per millimeter square. Now, by using these two values in the left hand side and the right hand side, find the value of d. Okay, so if you do the cross multiplication and divide with respect to pi and 40, so you will be getting the diameter as 123 mm. This is the diameter of a solid shaft. But this problem is not yet over. Okay, so for solid shaft, you need to use one more condition. So according to that condition also, you need to find out the diameter. What is the condition? In the problem, they have given angle of twist as 1 degree per unit length. So theta is equal to 1 degree. So 1 degree. So convert that into radian. So how to convert? Multiply by pi by 180. The value what you are going to get, that you need to substitute in the torsional equation. So per unit length is also given, that is 1 meter. 1 meter is equal to 1000 mm. 1 meter is equal to 1000 mm. That is the value of L. Okay. So you need to substitute wherever you will be having L. So the torsional equation T by J is equal to G theta by L. So T is equal to, just cross multiply this J towards the right hand side, that is to the denominator. So G theta by L multiplied by J. That is the equation what you are going to get. So from this equation, G is the modulus of rigidity that is given. So 80 into 10 to the power of 3. So theta is 1 into pi by 180. 1 into pi by 180, and L is 1 meter, that is 1000 mm. So J is 5d to the power of 4 divided by 32. So in the left hand side, you have T. The T value you need to take maximum torque 14.62 into 10 to the power of 6. So you do the calculation for this equation, you will end up the diameter with 101.623. So this is the diameter what you are going to get when you consider the angle of twist, that is 1 degree per unit length. So comparing these two diameter, you need to consider the 123 mm diameter for a solid shaft, because this is the maximum one. Second condition, you need to consider the hollow shaft. For this condition also, you need to find out the external diameter and internal diameter. How to find that? That is also very simple. But for that, condition is given. You need to see outer diameter or external diameter is twice the internal diameter. Okay, it twice the internal diameter. So now, so d naught is equal to 2 times the di. That means di is equal to 0.5 times the d naught. Very simple. Okay. So just divide by 2. So from this equation, so di will be equals to d naught divided by 2. So 1 by 2 is 0.5 times the d naught. Okay. So wherever you will be having di, substitute with 0.5 times the d naught. Let's see what we are going to get from this. So again, use the torsional equation. T by J is equal to tau by R naught. So R naught is for outer radius. So just do the cross multiplication. So you will be getting T is equal to tau by R naught into J. Okay. So tau by R naught. Tau in the numerator, R naught in the denominator, that is D naught by 2. Okay. So next one is J. J is the polar moment of inertia. Here we are considering for a hollow shaft. That's why pi by 32 multiplied by d naught to the power of 4 minus di to the power of 4. So next, so here 2 ones are 2 16s are 32 will get cancelled. So let's see, tau divided by 16 times the d naught multiplied by pi into d naught to the power of 4 minus, so di, I'm going to consider it as 0.5 times the d naught, 0.5 times the d naught. So from this, I'm going to take d naught to the power of 4 as common term, d naught to the power of 4 as a common term. and here d naught, and here 1 for d naught will get cancelled. Remaining term is d naught to the power of 3. Now, so in the left hand side, so T what we have considered, that is the maximum torque 14.62 into 10 to the power of 6 equals to, so in the numerator, tau value is the maximum shear stress, that is 40. In the denominator, you will be left out with 16 multiplied by pi into d naught to the power of 3. So next within this bracket, whatever the value we have, that is 1 minus 0.5 to the power of 4. If you do this calculation, you will get 0.9375. Okay. So now in this equation, so do the calculation. Okay. Either multiplication or you divide. So you will get D naught. Finally, D naught will be 125.68. So after finding this outer diameter or external diameter, consider that in the equation where we have, so di is equal to 0.5 times the d naught, you will get internal diameter as, or inner diameter as 62.84 mm. Okay, so this is one portion. Again for this hollow shaft also, you need to consider the angle of twist, that is 1 degree per unit length. So in that condition, what diameters we are going to get? Let's see. Same equation, T by J is equal to G theta by L. So from this, just cross multiply. So T is equal to G theta by L into J. So G is 80 into 10 to the power of 3. So L is 1000 mm, 1000 mm. So theta is 1 into pi by 180. And here, this is where you will be finding the difference. So J is equal to pi by 32 d naught to the power of 4 minus di to the power of 4. Again, di is 0.5 times the d naught. Substitute that value here. So take d naught to the power of 4 common. So 1 minus 0.5 times the d4. And so here, okay. So here, if we do the calculation, mathematical calculation or operation, you will be getting d naught will be equals to 103.28. Please remember, in the previous condition, it was d naught to the power of 3. But here, you will be finding d naught to the power of 4. Don't get confused. If you do d naught to the power of 3 like this in the previous condition, you will not get this answer. This is where most of the students will do wrong. Okay. Because here we are not dividing. Here we are not dividing anything. Okay. So here we are not considering or not. Like where we have considered. So here we have considered, right? Here we have considered or not. So in this equation, we are not considering that one. We are considering T by J is equal to G theta by L. Shear stress we are not considering. We are not considering R. Okay. So that's why please don't forget. Here we are taking T naught to the power of 4 as common. And for this, we are finding the diameter. That is 103.28. After finding this, just substitute in the equation which is given, di is equal to 0.5 times the d naught, di will be equals to 51.64. Okay, so for these two conditions, before considering the angle of twist and after considering the angle of twist, the diameter will be maximum for this condition. Okay, before considering the angle of twist. So you need to use this diameter 125.68. Di internal diameter is 62.84. Okay, so these are the values you need to find for this particular problem. Little bit lengthy, but easy. Okay, so we'll continue with the next session with the next problem. Thank you.